Happy holidays, y'all. I am so happy to be back making a video for y'all. I've been working real hard out here, and this video is going to be about putting this system together. And it's going to take a few videos to do this. It's going to be a long process, but I'd like to get started with this one. Where are you going, Rona? Where are you going, girl? So let's get started. I'm gonna walk you through some of the things I'm doing, some of the plans I've made, and some of the equipment that I'm using. I'm gonna start with the elephant in the room. You might have noticed what's behind me, and there are three of them. Yes, we have the Chinese pronounce it Day inverter, and so the elephant in the room, and I know that I'm going to get comments on it if I don't talk about it, so let's just go ahead and get this out of the way, and then I'm not going to offer much in the way of comments afterwards. But these inverters are made in the factory that produces the solar inverter. And when I was shopping for inverters, I had to make that decision. And some people say that if you buy these in the US, that you're buying them on the gray market. I don't see how that's possible. If you look at the model number, it starts with SUN, that's like SunSync 8K, and it ends US. So yeah, it's not gray market. Now, Solar does have an exclusive to sell the solar inverter in the US. This isn't a solar inverter, and they have now figured out how to keep anyone from being able to buy a split phase inverter in the US. They just basically told the factory, we're not going to buy anything from you if you sell split phase inverters to anyone but us. So fortunately for me, if it all works out, I had purchased 6 of these prior to that. And so I've had these for some time, waiting for the project to get to this point, and I'm happy that it is at this point. Now, when I decided to go this route, I went this route for a few reasons. I like the company that makes these, and the cost of these is just under 1/3 of what it would cost to buy a similar capacity solar. And that's a huge amount of money. To get this system would have been $21,000 for each of the projects, for mine and my friends. So I had to make that decision. And there are risks involved. I am certain that the customer service and the customer support would be easier if I had paid the money to buy Solarc. I could just call somebody right up the highway and talk to them. There's also the question of warranty and whether the support will be there if I need help 5 years from now, 10 years from now. And I would think that either way I went would be a risk. But I'm pretty sure that the company that actually makes the inverters, both these and for Solarc, they're probably going to be here in 10 years. They're, for one thing, supported by the Chinese government. And Solarc probably will be here in 10 years as well. Whether or not they're getting their inverters from this same factory remains to be seen. They have talked about making these factories in the US. These inverters in the US. I think that's going to be a real challenge. I think that designing a product like this is a piece of the puzzle. I think setting up a factory that actually manufactures a product like this is a much bigger piece of the puzzle. At least according to Elon Musk, who, when he designed the Tesla, said the design is 10%. Setting up a factory that can put it out is 90%. So to think that you have the design so you can just bring it back to the US and manufacture it, I don't think that that's a gimme at all. So that's about as far as I want to take that conversation. I've taken a risk by buying these. I think you take a risk either way, and it remains to be seen how that will play out in the future. If the motherboard of this thing goes out or some major component of it goes out, will I be able to buy a part? I suspect I will. We'll see. But for now, this is what I'm doing, and I'm installing them. And so I want to spend the video talking about how I'm installing this whole system and how I'm putting it together. I just needed to get that out of the way. So we have talked about how I built the building and how I built this wall so that we have these battery boxes that come out. And I didn't want the battery boxes to be in the way of accessing the equipment, so I made it to where they would slide in underneath the wall that all the equipment is mounted to. So I have 3 of these inverters. Each is good for 8,000 watts. So that gives me 100 amp service for the home. And I have never seen on my monitor more than 19,000 watts for a very brief period of time. So I think 24,000 watts will probably be adequate. Now, these inverters say that they need 20 inches in between them. And so they're spread out on this wall quite a bit. And that is also why I had to drop the battery combiner box down, offset it, and then the inverter is raised up so that the airflow could come across the top. These panels are recessed back so that the air can flow across. And then I have the mini split that will keep the whole room cool, because I've got not just these 3 inverters, but also the 2 Solar Edge inverters that are going to tie in. And because this battery combiner box drops in below, and because I've got the batteries down underneath, I was limited as to what I could do. I would love to have put just a gutter underneath that went all the way across and fed all this stuff down into it. You see that commonly done. I wouldn't have been happy with just having a lot of exposed wiring, and I'm too fussy for that. I have to have things a little more organized than that. But this works because the whole back side of this acts as a chase for the wiring to happen. And I went ahead and bent conduit elbows to come in. These inverters have these bushings that bring the wires in, and I just took 5 of the bushings out and ran these conduits in so they come in back behind the wall. Let's go ahead and show you what that looks like back here. So where they come in, I've got 5 pipes. Some of them won't be used, but 3 of them for sure will be used, and the other 2 will be used for DC PV. I'll have DC coupled PV and the AC coupled PV. So the conduit that comes in, the first one that you see that comes in goes to the load panel. And so this has a little pull elbow on it. And then that comes up into the bottom of that panel, which is a load panel. This panel is the grid panel. So let's talk about that. But before we duck out of here, I have a ground bar here so that all the equipment grounds will come in and tie together on this one equipment ground lug. And it'll have a 6-gauge wire that runs to the main grounding post on the service. And then each of the pieces of equipment will have a wire that comes into it. On the smaller things like the inverters, I'll have a 10 gauge wire that runs in. And on the panels, which are rated at 125 or 100 amps, those will have a 6 gauge wire that tie in. And so all of the equipment will be grounded. There'll be you see like a 6 gauge wire here that's tied into the battery combiner box, and that goes in and ties to the bus. And you've got a 6 gauge wire that ties into this ground lug for the equipment ground, and it goes in and ties into that. This panel was just installed, so I haven't tied that in yet. So let's look at the distribution. Oh, hello, Rona. Such a joy to have her come join me. So the way this all is arranged is the inverter has 3 AC connections. You have the connection to the grid, you have the connection to a generator or the AC coupled inverters. We'll talk more about that in a minute. And you have a connection for the load. So this goes to the house. So what these panels do is the wire coming from the grid, because I think I'm going to have a grid backup. This is going to be an off-grid system with a grid backup so that I can use the grid when I want to. There will be a transfer switch that will be mounted here, and that will act so that I can either use the grid or not use the grid. I can bypass this system in its entirety and feed the house just off the grid. So the 3 gauge copper line will come down from the grid, go through the transfer switch, and if I want to bypass this entire system, it will just feed right back up to the house panel. But in normal operation, what will happen is the grid will come in, it'll tie into this backfed breaker, and then each of these 60 amp breakers will conduit over and feed one of these hybrid inverters. And then that will tie in to this port. And then this port is the load. So this port supplies power to the house. And so each of those will come in and tie in with the conduit up into the bottom of this panel, and each will tie into one of these 60 amp breakers. And then it will take this 125 amp breaker, which is just a 125 amp panel, so it's got a 125 amp main breaker. And that 125 amp main breaker will feed to the line that goes to the house. Now, there will be a main breaker on that line as well. And it is possible, I think maybe likely, that I'm going to change this 125 amp breaker to a 100 amp breaker, because that 3 gauge wire that runs to the house, it can, this system doesn't have the capacity for more than just a small surge to run more than 100 amps. But I would be a little more comfortable having a 100 amp breaker on that 3 gauge wire. It's rated for 125 amps, but I kind of like a little bit of headroom. So that's my thought. These 320 amp breakers are just for circuits in this building. One is for the mini split, one is for lighting, and one is for the convenience outlets that'll be used for when I'm working out here. And I have the lighting separated, even though it'll be LED and won't have much draw. I have the lighting separated because if I'm using a tool out here and I blow the breaker, I don't want to be in the dark. So I like to separate lighting and equipment, even if I don't think I need to, because the lighting is only going to draw maybe 20 watts. All right, so you've got a grid combiner distribution box. You have a load combiner distribution box, or basically it gathers the supply and takes it to the load. And then there's a panel that's going to get mounted here that will be, and this will be a very manual transfer switch because it's not really a transfer switch, but there will be a breaker here, a breaker box here that will have 6 40 amp breakers in it. And there will be a 40 amp breaker for each of these Solar Edge 7600 watt inverters. And there will be a 40 amp breaker, well, 35 amp breaker for the generator. And there will be 3 40 amp breakers that send that power to the gen port on the 3 hybrid inverters. And what I mean by manual transfer switch is you should never have the generator and the AC coupled inverters on at the same time, because what's going to happen is if the sun is shining, those AC coupled inverters are going to dump power into that rectifier board of your inverter, of your generator, and it's going to blow up your generator. So there will be good labeling, not labeling that can fade, not labeling that can come loose, but screwed on plate labeling that will say these breakers cannot be on at the same time as this breaker. And if I feel less comfortable, I'll create my own interlock for that so that you can't physically have these 2 breakers on at the same time as the 3rd breaker is on. So that's a iffy, sketchy kind of thing, but to do it with transfer switches is far more expensive. Transfer switches are very expensive, as it turns out. 100 amp transfer switch I'm finding for $500 and often unavailable. But if you need one, I did find them on eBay for $250 for a GE 100 amp transfer switch. They're gonna come from Puerto Rico and they're gonna be here in a week. But half the cost of if you go down and buy it at the electrical supply house or the Lowe's or one of the places online in the US, Amazon or any of those places. It's going to be $500 at those places. So I have one on its way. It'll be here a couple of days after Christmas. The next time you see a video here, it'll be hanging on the wall. That'll go here. And then this panel is it's very inexpensive, but they keep zeroing it out. But I'll have it in a few days. Eventually they'll get one in stock and I'll get it hanging on the wall. In the meantime, I've got plenty to do. So let me show you a few more things. So the battery combiner box, we've seen this before. I did a lot of this prep work in the house, in my office, getting ready for this project. Before I even had batteries, I got this prep work done for all of these breakers installed. At the time, I only had 6. I've added 2 more because I have 8 batteries that are going to come across this floor and be mounted here on this floor. Actually, 7 will fit there, and then there'll be 1 that'll be out here in front. But they're all on caster wheels and can roll around and can be disconnected. The batteries themselves, because there are so many of them, they're not ever going to have a large amp draw. These are 1/aught welding wire cables, fine stranded, Royal Exeline cables. And then each of those is on a 175 amp breaker. And then after they come off of this 1000 amp bus bar, they go into 3 250 amp breakers, and each of those 3 250 amp breakers goes to one of the hybrid inverters. And so the first one is already cooked up. I'm running 2-aught copper for those. I really was planning on using 1-aught, but because it is actually rated, this is a 90C rated cable, it actually is rated to do it. But because I added more batteries and needed more wire, I had to buy more cabling anyway, and I decided, well, let's just up the size of the battery cable, I mean the inverter cable, to 2-aught. So this is a 2-aught wire that's going in here. And let me just mention that, and I've talked about this before, these lugs that you purchase and the hydraulic crimpers that you purchase are for the rest of the world, not for US American wire gauge. So they're all in metric sizes. This is the 1-aught uses a 50 millimeter clamp in the hydraulic crimper, and that's about the right size. You don't have to modify that one much. But the next size up for the 2-aught is a 70 millimeter, and that doesn't do a very good job of crimping. The cable won't come out, but it doesn't do a very good job of crimping it down. So I modified it like I have some of the other sizes, and I did that by going out to my grinder, and on the side of the grinder wheel where it's flat, I ground the faces of those 70 millimeter dies down so that they would grip down tighter and form a better oxygen-free joint, so that these lug connections will last longer. And so then I brought this through a 2-inch bushing, and I went ahead and used a piece of flex cable that I had off the side to run over to that inverter. But I went ahead and cut a slot in the bottom of it because I'm going to have the wires, the cables for this, share this outlet, and it'll come in up into the inverter here. This one will come in over here and come in. And these cables need to be the same length. So this negative and positive cable coming through here and coming up into the inverter over here, the length of that cable determines the length of all the cables that supply these inverters. So even though this one's going to be really, like, I could get it in 18 or 20 inches, it's going to instead have to be 75 inches of black and 70 inches of red. And this plus 24 means that the one that established it was 70 plus 24. Now, when I get ready to set up this one, I have to measure this cable, and that looks like it might be 26 or 27 inches, which will mean that the red will become 67 inches because it's the total to the bus bar that matters. And then that will be the case on all of the batteries as well. The farthest battery determines, and I've already made up the cables for the one that's the farthest. So the one that's the farthest determines the length of all of them. But when you make the batteries cables up, you have to take into consideration the difference in the cable that runs from the breaker to the bus bar and make the total of that red the same. The red and the black do not have to be the same length, but the total trip to the battery and back has to be the same length. And because the negatives can all be the same regardless, the longest trip is what establishes it. So the difference is going to be in how long the connection from the breaker to the bus bar is. And then you're just going to have to do the math. And when I get done, there's going to be some coiled cable inside this box. You know, this box seems so large But it has to be this large because when you're trying to balance battery leads, you have to figure out where you're going to put that battery lead. And I'm going to probably have that battery lead here rather than coiled up down by the battery, or I'm going to have a little shelf here that comes out, and the battery cables will come out of the bottom of the battery combiner box through these bushed openings, and they'll lay on that tray, and then they'll come down into each of the batteries. And I'll set these up intuitively so that this is battery 1, 2, 3, 4, 5, 6, 7, 8, so that you can just imagine. And I will also label each of these breakers, but I want it to be also intuitive. I've got it set up so that you can get to all the controls everywhere, and so that it all has good ventilation. That panel will go away. Once I get this panel set up and all the conduiting is done and everything is ready to switch over, then that panel will go away and these will feed into the new panel on this side. And then all the panels will have the appropriate walk up. These are a little bit high, but they're not that high. They're kind of eye level to me, and I can easily reach them. The only spacing problem that I really had was that the mini split's a little close to the inverter, but if you see, these inverters are even higher than these. So if I had moved it over to this wall, it would have been even closer to the inverter. So I only had one other option, which would have been to bring it all the way around to this wall, but then I would have had exposed conduit, and I just decided not to do that. It's going to look really nice when I get done, and I think it'll work well also. So, back in behind here, and if you look up, I know it's going to get dark up there, but this iPhone's pretty amazing. It'll probably compensate pretty well. So that opening right there, and you see those two yellow wires coming in, those are just temporary power for during construction. Once I get this system powered up, I will take those out and seal that opening up. The yellow wire there, that's a 12-2 Romex. That is running to the disconnect for the mini split for the outside unit, and that disconnect is already installed. The black wire you see there running across at a diagonal is well, right there. That is the communication wire and the feed for power for the inside unit for the mini split. And then the last thing that I needed to have hooked up for the mini split, because I got the Freon lines, showed you this in a previous video. The Freon lines are basically the extra coil is laid in up near the ceiling instead of coiled outside. I don't really like that coiled outside thing. But the drain line I needed to run, and what I decided to do is run it down low and not take it out on top of the rainwater tank where it was always going to be drippy. So what I did was I took some, I believe that's 1-inch PVC, and I ran it up, and instead of using fittings, I just used my heat gun and I heated it up and bent it so that it's a nice clean sweep and less prone to collecting algae. And then and this is real important, y'all. And then I tied the drain from the mini split into that. Now, air conditioning drains clog up. Not if, when. They will clog up. Oh, hello, Rhoda. They do clog up. And so when that clogs up, because what can happen is you can end up with drips on the floor. If that joint up there were to ever leak, it would be below the cutoff for the mini split, and it would end up dripping on the floor. So I recognize that, and what I'm planning to do, and you will see this someday, is these first two batteries, they will end up with a piece of polyethylene sheet over the top of them to drape them, because I just don't want to ignore that situation and end up with a water puddle down inside my battery. So I'm trying to think it all through, and I think I've got it pretty well figured out. There are things that I'm still figuring out, and let me tell you, y'all, if it's made out of wood, it's a gimme for me. I can do wood. And I've done an awful lot of electrical work in my time, and I've managed an awful lot of electrical crews and a lot of electrical jobs. But when it comes time to do the hands-on nitty-gritty stuff, 4 switches in a box with all the mess of wire, oh my goodness. Oh, well, are you having fun? It is a mess, and I will hire somebody to come do that. But this is something I'm doing myself, and what I'm learning is, y'all, there's skills to this stuff. Bending conduit to where it all lines up, there's skills to it. Now, I'm lucky. I have one of the ways my brain works is it sees things in 3 dimensions over time. So when I have a piece of conduit to bend that has to come and jog away from the wall and turn in and then tie into a fitting over here, and you got to visualize how to do the bends, I can do that part. But holy moly, the guys that do this work, there is experience required, and I see people do really beautiful work with one of these tools. I never really gave them credit. I like to imagine that I give the tradespeople credit, but every time I do one of those jobs that I haven't done before, I'm reminded in a real hands-on way that the tradespeople, they're really good at what they do, and they have years of experience, and even the helpers have experience. And so when we think that we can look on a YouTube video and learn how to frame a house or build a cabinet or wire a house, or plumb a house, well, yeah, you can. You can't learn all the things that even the helper on that job knows, though, and they make the day go a whole lot quicker. So getting this put together is going to take me longer than if I had my electrician here doing it. That's a fact. I will be bringing you another video as soon as I can, and I have batteries to put together too. Please subscribe to the channel. I know a lot of y'all are watching this and commenting and enjoying the videos but not subscribing. You got nothing to lose. It won't hurt. Hit that subscribe button and hit that bell too. That might hurt. You might get a notification that tells you that the next video in this series is ready to play. And if you didn't enjoy this one, boy howdy, that would be a torture to have to watch the next one. But hit that subscribe button for me. Please, let's get those numbers up. And I really appreciate the comments I've been getting. I have some of the most kind subscribers. It's just amazing to me. somebody came in and commented today on a video that was a week old just to make sure that they didn't forget to wish me a Merry Christmas. Let me not forget to wish y'all a Merry Christmas. And we have some amazing weather. In the next 10 days, our high temperatures are going to be in the 70s and 80s every day, and the lows are going to be down in the 60s. It's just amazing. And for the 60% of my audience that actually isn't in the US, that's 23 to 28 C is our high temperatures for the next 10 days. Holy moly. I'm not even rolling up my tools. I'm just leaving them out. They can't get rained on, and it's not getting cold. It's just amazing. So it's been a great journey. Stay with us. Keep coming back, and we're going to keep moving forwards. And it won't be too long. We're going to fire this thing up, and we're going to run the house just off the sun, because what I've built here is a generator with an endless fuel supply. I wanted to buy a generator, but how do you keep the propane tank supplied if things get wonky? My friend had a generator in the freeze last February. When the propane tank went dry, she didn't have any power anymore, because there wasn't any propane truck gonna be bringing her any propane deliveries during that storm. And there are other things that can happen that can take the grid down and keep you from getting your carbon-based fuel supply. So this here is a generator with an endless fuel supply, and that's why I'm doing it. And I appreciate you coming back for this video, and I look forward to seeing the comments.